Okay, we'll start problem 16 here. So we're going to get some practice solving logarithmic and exponential equations. Now, whenever we solve a logarithm, I've already talked about the importance of the definition of a logarithm. It's we have to know that, okay? And because most of the time when we're solving logarithms, we're going to at some point use the definition of a logarithm. Okay, this definition here, and along with that, we need to know our properties of logarithms. So let's go ahead and solve part A. I got log base 2 of 3x minus 2 equals 4. Solve for x. So the first thing I want to do is get rid of this logarithmic notation that I see. Okay, and I'm going to use the definition of a logarithm to convert that to an exponential equation. Okay, so y equals log base a of x means that x equals a to the y. 3x minus 2, that's the input. So that's me all alone on the exponential. 2 is the base, 4 is the y value, so 2 to the fourth would be on the right side. 2 to the fourth, 2 times 2 times 2 times 2, that'd be 16. So I got 3x minus 2 equals 16. And now I'm back on more familiar ground because I don't have any logarithmic notation going on. You know, so it's solve for x. If we add 2 and then divide by 3, x is 6. Okay, now we have to check our answers whenever we have a logarithmic equation, because this is one kind of an equation where we can sometimes get these extraneous solutions that come up. Okay. So what I'm saying here is that 6 may or may not be the right answer. We don't know until we check it. Okay, so I got log base 2 of 3 times 6 is 18, minus 2 is 16. Okay, so is log base 2 of 16, is that equal to 4? Well, 16, that's the same as 2 to the fourth power. Okay, 2 times 2 times 2 times 2, that's 16. And if I write it like that, then I know powers can come out of logarithms. So I can pull this 4 out front. I have 4 times log base 2 of 2. Log base 2 of 2 is 1. Okay, so the answer is 4 times 1 or 4. That's what I had to get to on the right. Okay, so I can go ahead and circle x equals 6. I know that's correct. Okay. Here's another example. So part B, we got 10 plus log base 5 of 8 minus 3x equal 13. If we subtract 10 from both sides, log base 5 of 8 minus 3x equals 3. So then let's convert that to an exponential form. I got, okay, 8 minus 3x, that's the input. So that's be all alone on the exponential. 5 is the base, and 3 is the y value. 5 cubed, 5 times 5 times 5, that's 125. Okay, now I'm back on a more familiar ground because I don't have any logarithmic notation going on anymore. So if I subtract 8 and then divide by negative 3, x would be negative 39. Okay, is that right? Well, x can sometimes be a negative, right? Y can't be a negative. And so let's see, x is negative 39 there. So is it true that if I take 8 minus 3 times negative 39, let's see, what does that give me there? 8 minus 3 times negative 39 is 125. Okay, so then log base 5 of 125, well, I got log base 5 of 125, that's the same thing as 5 cubed. Okay, 5 times 5 times 5, that's 125, and powers can come out of logarithms. So I got 3 times log base 5 of 5. Log base 5 of 5 is 1. So I get 3 with that. And then plus 10. So is 10 plus 3 13? Yes. Okay, so x equal negative 39, that'd be the correct answer there. Okay, now for whatever reason, if I were not getting 13, then I'd cross off that number and there wouldn't be any solutions to this equation. Okay. Let's try problem 17 next. So in problem 17, I want to solve the equation log base 5 of x plus 6 plus log base 5 of x plus 2 equals 1. Okay, so if I'm adding two logarithms together, I can get a single logarithm by multiplying the inner terms. I'm going to start by doing that. I got log base 5 of x plus 6 times x plus 2. That's equal to 1. X plus 6 times x plus 2, that'd be x squared plus 8x plus 12 when I FOIL that out. Okay, now at this point, let me use the definition of a logarithm, and I'll convert that to an exponential form. So x squared plus 8x plus 12, that's the input. Okay, so that's me all alone on the exponential. 5 is the base, and 1 is the y value. Okay, so 5 to the first, that's 5. And now I'm in exponential form. If I subtract 5, x squared plus 8x plus 7 equals 0. And I'm back on a more familiar ground now because I don't have any logarithmic notation going on. So this quadratic here is going to factor nicely. X plus 1 times x plus 7. Okay, and then if I set each of those equal to 0, I get x equal negative 1 and x equals negative 7. I got to check that. So let's plug in negative 7 first. Whoops. Negative 7 plus 6 is negative 1. And you can't take a log of a negative number, right? I'm also going to get negative 5 right here. You can't take a log of a negative number. So negative 7, that'd be an extraneous solution. Go ahead and throw that away. Now I want to know if x equals negative 1 is going to work out. Okay, now, by the way, I'm not crossing off these numbers just because they're negative, right? Like you can and will sometimes get a negative value for x, okay? You gotta check it though and make sure that you get a true statement. So is x equals negative 1 going to produce a true statement? Well, negative 1 plus 6 is 5. Log base 5 of 5, that's 1. Plus log base 5 of negative 1 plus 2 is 1. Log base anything of 1 is always 0. It doesn't matter what the base is. Okay, 1 plus 0 is 1, and that's the number that I see on the right. So x equal negative 1, that's correct. Okay. Let's try part B of this. So we got 2 times log base 3 of x plus 4 minus log base 3 of 9 equal 2. Let's solve for x. Okay. Well, now before I use log 2, because I'm subtracting these two logarithms, I need to make sure that I don't have a number in front of the logarithm. 2 is in front of this first logarithm, so let's go ahead and use log 3, and we'll pull that back inside of the logarithm so that's a power of the inner part. Okay, so I'm going to have log base 3 of x plus 4 squared minus log base 3 of 9, that's equal to 2. Now I'm going to use log 2, and I'm going to divide these two terms inside this single logarithm. Okay, so I got log base 3 of x plus 4 squared divided by 9, that's equal to 2. And then I would say let's use the definition of a logarithm, and let's get rid of this logarithmic notation here that we see. And let's see, x plus 4 squared over 9, that's the input. That's me all alone on the exponential. 3 is the base, and 2 is the y value. 3 squared is 9. Okay, if I multiply both sides by 9, x plus 4 squared equals 81. I don't have any logarithmic notation anymore, right? So that's good. That's what I wanted. Let me take the square root of both sides. X plus 4 would be plus or minus. The square root of 81 is 9. So then if I subtract 4, x would be 9 minus 4 is 5. And then negative 9 minus 4 is negative 13. Okay, I need to check those. So let's go ahead and plug those numbers back in the original equation. By the way, always plug the numbers back in the original equation. Nothing that's been simplified, you know, beyond that. Okay, because you you may have a true statement then at that point. Okay, but you know, this is the original equation. Okay, so let me go ahead and plug in negative 13 there. Negative 13 plus 4 is negative 9. I can't take log of a negative number. Okay, so negative 13, that would be an extraneous solution. Throw that number away. That's no good. Now I want to know, is 5 going to work out? Okay, well, same deal. I plug that in the equation there. 5 plus 4 is 9. I got 2 log base 3 of 9 minus log base 3 of 9. That would be log base 3 of 9. Okay, so is log base 3 of 9 equal to 2? Well, 9 is the same as 3 squared, right? And then I can pull the power in front of the logarithm using law 3, excuse me. So I'm going to have 2 times log base 3 of 3. Log base 3 of 3 is 1. Right? So I got 2 times 1, that's 2. Okay, 2 is the number that I had to get to. So 5 is going to be kept. Okay, negative 13, that'd be extraneous for us. Let's go ahead and try problem 18 next. So in problem 18, we want to solve this equation here for x. Okay, now I'm subtracting 2 logarithms on the left. So using law 2, I'm going to get a single logarithm by dividing the inner terms. Now here I'm using the ln notation, so what? Okay, the properties of logarithms apply for when you have any base, okay? So I'm going to have the ln of 3x plus 11 divided by x plus 2 equals the ln of 4. Okay, now with this logarithmic equation, I got ln on both sides. That means that I can set the inner terms to be equal. Okay, and I can lose the logarithmic notation in that case. So I'm going to have 3x plus 11 over x plus 2 equals 4. Solve for x. If I multiply both sides by x plus 2, on the right, I'm going to have 4 times x plus 2, that'd be 4x plus 8. And then subtract 3x and then subtract 8. 4x minus 3x is x. 11 minus 8 is 3. Okay, so I'm getting x to be 3. You need to check that. So let's go ahead and plug 3 into the equation there. I got 3 times 3 is 9, plus 11 is 20. And then over here, 3 plus 2 is 5. Okay, I got the ln of 20 minus the ln of 5. Well, I can divide those inner terms. 20 over 5 is 4. So that would give me the ln of 4. The ln of 4 is just a number, right? So I got the ln of 4 equal the ln of 4. That's true. So x would be 3. That'd be the answer. Okay. In part B, we have an exponential equation. Okay. You don't need to bother checking your answers when you have an exponential equation. That's only when you have a logarithmic equation. So let's go ahead and solve this guy here for x. Now the bases aren't going to match up nicely. Like, 4 to what power gives me 6? I don't know. Or 6 to what power gives me 4? I don't know. So in that situation, I'm going to take the ln of both sides. okay? And the reason for getting logarithms involved with this is because now I can use the properties of logarithms, right? I know powers can come in front of logarithms. So I'll have x plus 1 coming in front. That'd be times the ln of 6 equals 2x minus 1 times the ln of 4. Okay, and then let me distribute ln 6 into these two terms on the left and then ln 4 into these two terms on the right. And the next line is going to be x times the ln of 6 plus the ln of 6 equals 2x times the ln of 4 minus the ln of 4. Anything involving x, let's get that on the left. All the other numbers, let's get it on the right. So I'm going to subtract 2x ln 4 from both sides. And then I'm also going to subtract ln 6 from both sides. Okay. Now, the next thing is I'm going to factor out an x on the left. So if I bring out x from these two terms, I got ln 6 minus 2 ln 4 left over. ln 6 minus 2 ln 4, that's just a number. You know, like 5 is a number. So I'm going to divide by this number. And x would be negative the ln of 6 minus the ln of 4 divided by the ln of 6 minus 2 ln 4. Okay, that would be the answer. Now, if they wanted to know what that is in decimal form, like if this is a story problem or something like that, where they're asking for a measurement, you know, you're not going to say, oh, it's a negative ln 6 minus ln 4 divided by ln 6 minus 2 ln 4. No, you're going to give them the number, whatever that is. Okay, so let's go ahead and type this into the calculator. We have negative ln 6 minus the ln of 4. And then we're dividing that by ln 6 minus 2 ln 4. Whoops. Minus 2 ln 4. Okay, and I'm going to close up the parentheses there. So I get 3.24 roughly with that. And yeah, that'd be the answer. Okay. Now, whenever you're solving an equation, always keep the answers in exact form for me. Okay. Like, there's no reason to go to the calculator and type this in, unless this is a story problem. You know, then give the answer, you know, in just the single number form, whatever that is. All right. We'll go ahead and stop the video right there, and I'll pick up with problem 19 in the next one.